Okay, so now we're recording. There's a final exam announcement posted on Canvas. We just talked about that. And I went over the times for the final exam. You can take the final Tuesday, December 6th from 8 to 10. You can take the final Wednesday, December 6th from 8 to 10, or at your scheduled time, which is Wednesday, 10:30 to 12:30. Okay, so obviously that's next week, and what we're looking at is in 2 days, which is the 30th, chapter 18. So, now go with questions.
Chapter 8, okay, number 17.
Number 17, so this is chapter 18.
This isn't like a work it out, I don't think, or it might be. But is that like based on what the appendix
okay.
gives us? Like, are we just looking at that number, or are we doing like...
Okay, so here's number 17. What it does is, it is kind of based on the appendix. It gives you, what is it, A, B, C, D, E, 5 different things. It says, okay, you got neon gas, you've got SO2 gas, you've got sodium solid, sodium chloride solid, and hydrogen gas. And it says arrange them in order of increasing entropy. Mm-hmm. So, an easy thing to do, because y'all are doing end of chapter, right, is just look everything up, the entropy's in the back of the book, and rank them that way. But if I were to ask you this question, I'm not going to give you the whole appendix. I'm wanting you to rank them entropy based on, I'm about to scroll on my screen here. Well, maybe, where did we talk about it? Okay, here, yeah, the qualitative predictions, right? Solid, liquid, gas, like gases have higher entropy than liquids, liquids higher than solids, and then compare molar masses for like molecules, etc. So I think that was your question, is this an appendix thing, or is this a ranking it based on what I know? And it's based on what I know. Okay, now, some of these are hard to tell because it's an end of chapter and it knows you have the appendix. But do you guys agree that the highest entropy, I'm going to write them over here, like lowest entropy to highest entropy, okay? I like to pick out extremes first. So what's the first thing you're going to look at, you think? Solids. Okay? Where are the solids going to go? Solids have got to go up here. Okay? So which of those solids do you think has the lowest entropy? Entropy's disorder. Lowest entropy would mean it's the most ordered.
Maybe sodium? Like the elemental form of it?
I think the elemental form of it. Because it's just Na. That's exactly what I think.
Nothing else added.
Mm-hmm. Okay. So that takes care of those. Mm-hmm. Okay, now the highest entropy. All these are gases.
Yeah.
So where are we going to go next with that?
Maybe elemental form of the gas.
Okay. Consider elemental form. Which of those do you think has the highest entropy, the most random?
I said H2, but I don't know if that's right.
Okay.
SO2?
Why'd you not go here first? That the highest is SO2.
Because I'm thinking it's a solid. That's what I'm doing.
Okay.
I'm thinking, yeah.
Okay. So this one, why do I think you should go there first?
Because there's other stuff in it.
Because there's other stuff in it. It's SO2. Okay, now, I'm going to be honest with you. On the next two, I'm not sure. Because neon is monoatomic. But I know that the molar mass of neon is 4 grams per mole. Hydrogen's diatomic, but y'all, it's pretty simple. It just has a molar mass of 2.02. So I'm not sure how to rank those. So what I'm going to do on those two is look them up in the appendix. Because I don't know if I should look at molar mass neon's more random. But this is diatomic. If instead of saying H2, if it said Cl2, oh, that's a no-brainer. Cl2 is more random than that one. Do you get my little kind of conundrum there? Diatomic and molar mass? Because they're not like molecules.
Can you look up the answer? Because in the online, it worded it so weird.
Yes. So what I'm gonna do is
If
go
it's
to my
the same
appendix
one,
2, and I'm gonna look up the entropy for where's neon? Hydrogen gas, neon gas. I feel like I'm right on it. I don't see neon. Did you try to look them up?
No, ma'am, I didn't.
Okay, let me look up hydrogen.
I'd rather have a physical look than an online thing.
Yeah, me too. Why do y'all have an online book?
Cheaper. Already figured.
Hydrogen gas entropy is 131.
Kind of well, but in terms
Joules
of study,
Kelvin.
I'd rather have a physical look.
Oh, much
But I
It's
so
easier
don't
to
want to be
study.
the one that has to carry it around all day.
Yeah,
My backpack is just
it's
here.
easier to carry and then it costs a lot less money.
Mhm. My backpack already heavy.
I don't see neon back here.
Are you in that,
I'm gonna take a guess and say that hydrogen would be bigger than neon.
First semester here, I took it.
The way it was doing it was like,
I have a couple.
Sodium.
I already got my cousin for next
and then it would have like a greater than or equal, like
I
greater
took
than or
it as,
less
like,
than
my fine
something.
arts study.
It's
Oh,
so
yeah,
weird because
okay.
maybe the first
It
year
said
was
sodium is lower than sodium chloride, which,
No, like it was. Let me see
No.
if I can find it. Are you on the inner chapter here?
Yeah, I mean,
I'm
She's
sorry.
trying to
No,
get
I
there.
can pull it mine out.
no,
It
it's
was
good.
like, if this is the one I'm thinking of, maybe it was a different one, but it was like greater than 0 or less than, I don't know, hold on,
Chapter 18 and a chapter, which one?
17. Okay, click on the answer. Oh, no, it doesn't. Never mind. I don't know what I'm talking about.
okay.
Okay. One of them, I'm sure we'll come across it because I would have underlined it, but it was, highlighted it. It was weird the way they put the answer.
Okay.
And there they have,
Sodium's
H.
the lowest?
Yeah, the sodium is the lowest, then it goes NaCl, then
Okay.
it goes H2,
Okay,
and then neon, and then SO2.
okay. I wasn't sure about those two, so.
So you just looked up the appendix for Ne and H2?
It
But
didn't
there
have
wasn't
any
any?
in the appendix, so I
Mm.
couldn't do that.
Can't really compare if there's
Mhm.
nothing there.
Mm-mm.
How did they expect us to do it though?
I don't know.
Depends
Does,
on
does
what
it
you-
say why? Because this question in the book, it says
It
give
just-
the
it just
reasoning.
gives
Yeah.
a
It
letter.
doesn't give a reason.
it tells us
just
that
does.
too,
Oh,
but it
okay.
doesn't.
It says give the reasoning. Well, we've discussed the reasoning, right?
Yeah.
Solids are lowest, gases are highest. And then how do I distinguish SO2 was gonna be higher than hydrogen or
Because it
neon?
had most stuff going
It's the
on.
complexity of the molecular structure. That's what it is. It's more atoms making it up.
So from going lowest to highest, it's I'm gonna say the word sturdy. The sturdiest one, which has less going on in it, but out of solids, and then you just go the rest of the way down with the gases, right?
Mhm. Yeah, that's where you start, right? We separated our solids and gases, but then we had to organize the solids too. So that's when we had to look at sodium is just made up of atoms of Na. But sodium chloride, it's atoms of Na and Cl. Therefore, that's going to be a little bit more disordered.
So H2 has less going on in it
Than neon. It's going to be a molar mass.
That's what I was thinking.
Okay. And I won't do that. Like
Yeah.
I wouldn't give you those. I mean, I had trouble distinguishing those two, so I'm not going to throw those two. But I mean, I could ask this question, and instead of giving you neon and hydrogen, maybe one of my choices is just helium. Oh, I told y'all that neon has a molar mass of 4. No, it doesn't. Helium has a molar mass of 4. It helps if you look at the periodic table that's on the wall in the room. Right? Neon has a molar mass of 20. Hydrogen only has a molar mass of 2.
That makes more sense now.
Yeah, it does. Okay.
Literally 10 times the.
Mhm.
It's okay.
Okay. What else? Did y'all work the end of chapter?
Not yet.
Okay.
I literally didn't. I like skimmed through most of my notes and everything while we were in break.
I rewrote my
I
notes.
Oh.
I'll try to look at them at least every day.
Mhm.
I have a question
But
under
I touch my
31.
computer, no.
31.
So I worked it out, and I assume I got the right answer because
I use it.
click on the answer. Please. It says all temperatures,
And below.
and so when I calculated the temperature, I got negative 1500 K, and that's not possible. So is that why it says
Okay. Okay.
like all temperatures because you can't reach?
Let me organize the information here. Okay, we got A and we got a B. A, the delta H is negative 126 kilojoules per mole. This is 84 joules per Kelvin mole. B, the delta H is negative 11.7 kilojoules per mole. And the delta S is negative 105 joules per Kelvin mole. Okay? And so, y'all, it gives you two different scenarios. And the question is, at what temperature will it be spontaneous? Okay? So, it's going to this formula that the delta G is equal to the delta H minus T delta S.
Please don't die over, Hannah.
Now, remind me about what sign of delta G is spontaneous? What sign of delta G is not spontaneous? Because this is something I would think you should know. What's the sign? Positive or negative on delta G, and what does that mean?
Negative is spontaneous, positive is non.
Okay. Negative delta G means spontaneous, and positive delta G means not spontaneous. Okay, and we went over this when we were talking about delta G, but do you guys remember that mathematically, if the delta H is negative and the delta S is positive, that delta G will always end up being a negative number? Okay, so when I look up here, in that first scenario, delta H is negative and delta S is positive. Therefore, this one is always spontaneous. And I think that's the one you had the question about, right?
Yes, ma'am.
Okay, so when I solve for a temperature, you're right. When you solve for what temperature, you get a negative Kelvin temperature. Well, you can't do that because it's always spontaneous.
But you should just know that it's going to be always spontaneous because.
You don't even have to solve it. When you
Okay.
see the signs, you know.
Okay.
Okay, but now the next one, they're both negative. Well, if both the delta H and the delta S are negative, then we said it's spontaneous at low temperatures, right? How do you decide what temperature that is? Do y'all remember you have to rearrange this formula to solve for T?
Yes.
So you take this, to rearrange it to solve for T, you end up with T is equal to delta H divided by delta S. We plug in our numbers from B. What do we have to be careful about?
Converting joules to kilojoules.
Yep, you got to watch your joules and your kilojoules. And it doesn't matter which way you go, but like on the delta H, if I use negative 11.7 kilojoules per mole, then that means on the delta S, I have to use negative 0.105 kilojoules per Kelvin mole. And I saw
Should equal 111.
111.
Should equal.
Okay, 111 Kelvin. What temperature would that be? Celsius? negative 384 degrees Celsius, whichever, I don't know.
It asked for Kelvin.
Okay, it asked for Kelvin.
So how do, but on the answer it said below
Yes.
111.
How did you know it had to be below?
Is it because it has to do it at a low temperature?
Because both signs are negative, it has to be that or lower.
Okay, okay.
Yes, if both of these numbers had been positive, then it would have to be that or higher.
I have more, but I don't want to be the only one that
It's okay.
asks.
They want you to ask.
And I don't know how to do part B on 45.
45,
With the partial pressure.
okay. Let me get my information written down. All right, it says calculate delta G and the KP for the following equilibrium reaction. PCl5 yields PCl3 and Cl2. All right, that's A. Okay. We have a book. How would you go about calculating the delta G standard? You have a book. It's an end of chapter. I'm telling you that because that's me trying to give y'all a hint on how to do it.
Look it up. Is that what you're saying?
Mm-hmm.
I did mine mathematically. Should I not have done that?
Well, this is all we have at this point, right? Did you not look up the delta G's in the back of the book?
Oh, yeah. I'm sorry.
Okay,
I'm looking at
no,
for the
no, no.
reaction.
Yes, mathematically, but looking up the delta G's in the back of the book. Are y'all
For,
following?
like, each element.
For each of
Yeah.
these, right, and doing products minus reactants.
Yes.
Okay? So, and that's not what her question is, but I'm wanting to walk us all through it. Are y'all following me on that? Or write it down.
Write it down, please.
Okay. So, I'm going to go to the back of the book, and I'm going to look all this stuff up. So, P.
Would you rather me tell you? Because I have it already.
I would love that. PCl5 gas is
Negative 305.0.
negative 305.0. That's going to be kilojoules per mole. I'm not going to write that every time.
The next one is negative. You ready?
Uh-huh.
269.6.
Okay.
And then 0 for
Chlorine 0. Okay. What we're doing here, y'all, is we are actually using that top formula on the board. The products minus reactants. So the total products is negative 269.6. And when we say products minus reactants, it's going to be negative 269.6 minus a negative 305. Again, I'm leaving the units off, but I wrote them up there. It's going to have units. So, for delta G standard, I get 35.4 kilojoules per mole. Is that what you got? Okay. Then it says calculate KP. I don't have that formula written on the board, but it's this. Delta G is equal to negative RT times the natural log of K. Okay. So, I plug in, let's see, 35.4 kilojoules per mole is equal to negative. R is, I'm getting it off the board, 8.314 times 10 to the minus 3 kilojoules per Kelvin times mole. Temperature is in the book, it's 25 degrees Celsius, which is 298 Kelvin. And then it's times the natural log of K. So from here it's math. Natural log of K is equal to 35. 6.23 times 10 to the minus 7. That's,
Wait, how do you know what K is?
that's what you're solving for.
Oh, okay.
Now, I just worked out A, which is not what Emma's question was about, but
So now I'll call it.
now we're all on the same page. Okay. I'm gonna
Well, that'd be your first
change
order.
slides.
Starting to run out.
You need to look at this. It's that right there. Do you need to look at that?
Thank you.
Mhm.
I'm gonna try to put B over here so I don't have to change slides, okay? Let me do that. So here's B. B says calculate the delta G and it gives you partial pressures, okay? Why does it give you the partial pressures? Because you're using those to calculate a Q. Q stands for reaction quotient. How do you calculate a Q?
Products over reactants raised to the power of the
Just like KEQ. Products over reactants raise the power of the coefficient. So I'm going to take that reaction and I'm going to take what's the pressure of the PCl3, which it tells me is, oh no. Having a tough time distinguishing a 3 and a 5. Okay.
Oh boy.
Yeah. PCl3, it says 0.27 atmospheres. Chlorine, it says, is 0.4. I'm leaving off the atmospheres. Why? Because I know that Q doesn't have units. Okay? That's part of it. Part of it is because I don't want to have a bunch of stuff that gets my eyes all messed up.
So on there, does it tell you which ones you're looking for? Like,
No, it gives me all these.
Oh.
I'm calculating a Q. I have to know that this is how I calculate Q.
You just have to know which ones to put where.
Right.
Okay.
Which we know, right? Because
Right.
products over reactants raise the power of the coefficient. So what I've done is I've taken the PCl3, this times this divided by this. Equilibrium expression, that's what I've done here. Okay, so now I'm gonna calculate it. You don't have this calculated, right?
No, ma'am.
Okay, y'all gotta calculate it with me because you know what I'll do, right?
Fat tummy?
I'll mess it up and none of us will know because I'm the only one doing it and
I know. Here.
if I were doing it on a test, I'd do it twice, right? But y'all are my twice. 37.2 is what I got for Q. Okay. Now, what B asked for, y'all, and I kind of jumped the gun on doing that, it asked for delta G. Y'all, this is the formula. I knew that was the formula I had to do. Okay? So, if that's the formula, delta G is equal to delta G standard plus RT times the natural log of Q. I got the delta G standard in part A. Do y'all see that? This is the 35.4.
So all you gotta do is plug it all in.
I gotta plug everything in.
So
What
the-
I didn't have for this formula was the Q.
Remind me what the degree means again.
Okay, yes, the degree symbol, a little circle on the G, when I'm saying delta G standard, it's talking about standard state conditions. It's talking about 25 degrees Celsius,
One.
all gases are at 1 atmosphere, all solutions are at 1 molar,
Okay.
yeah. Okay, so to finish it out, I'm gonna plug in.
Is it the same temperature as the?
Yes, yes. Isn't it? Yeah, it does not give you a new temperature, so it's the same one. Again, you're watching your units the whole time. Delta G standard is 35.4, that's kilojoules, plus R, 8.314 times 10 to the minus 3, times T, which is 298, natural log of Q, so that means the natural log of 37.2. And watch your math. Yeah? Just, I'm gonna take the natural log first, and then I'm gonna start multiplying. I got 44.4. Okay. Next. Is that all? No, not all, she said.
We can always count on Emma.
55, I just wrote ask Miss Heard to explain. So I,
Okay,
I don't even
55.
remember what it was.
Can I move on, or give me wait a minute?
Oh, you go on.
Okay.
I'm just writing down everything I did on the calculator.
Okay. 55.
That's why it always takes me so long to put it in the calculator, because I always write it down first.
Okay. Sometimes, hang on, I'll tell you all this. It's so much easier to. Hang on, I'm gonna pause it a minute because I don't want. Okay, this is the problem. Predict the signs of the enthalpy, entropy, and the Gibbs free energy for the following processes at 1 atmosphere. Okay, I'm about to reorganize it. Ammonia melts at -60. Ammonia melts at -77.7, and ammonia melts at -100. And then it tells us the normal boiling point of ammonia. Okay? It asks for the signs of the H, the S, and the G. I'm about to talk this one out instead of reorganize it. I changed my mind. What does melting mean?
Turning into liquid.
Solid to liquid. Huh? Okay. In order to go from a solid to a liquid, what has to happen with heat?
Temperature has to increase.
Reaching certain temperature.
Okay. But I asked what happens to heat.
It's absorbed?
Has to be absorbed. Isn't H heat?
Yes.
If it's going to absorb heat, that means H has to be what sign?
Positive.
In order for something to melt, it's got to absorb heat. So doesn't that tell us A is melting, B is melting, C is melting? The delta H for every one of them is positive.
Oh, so when it asks for the signs, it asks if it's positive or negative?
Yes.
So that's, okay.
Oh, so that's what I was confused about, and what signs it meant.
What'd you think? Signs? Yeah, it means positive. Because that's what all this is. Thermodynamics is all about positive or
It's
negative.
just asking you to, it's not asking you to do math.
Correct.
Okay.
It's not asking math, it's asking you to think critically about
Okay.
what's going on. So the delta H is positive. Okay?
Makes sense.
Now, that's the answer for H. For A, B, and C, H is positive. Now let's go to S. Melting, y'all already said it. You said melting is going from a solid to a liquid. What's happening to entropy when that happens?
It's increasing.
It's increasing. Solid to liquid is increasing entropy. So the fact that it's melting in every situation tells us that the S on every one of them is
Hot.
positive. Okay? Are we all together? Yeah, okay, now the G, that's the tricky one. Here's what I think you should think of on G. And I said this when we introduced G. G is Gibbs free energy. Think of it like this. Will it happen? Will that happen? And you just told me on the previous problem, 2 problems ago, I'm about to jump slides, right here at the bottom left. Y'all told me if the delta G is negative, it means spontaneous. Y'all, that means it will happen. If the delta G is positive, that means it will not happen.
So if they're
Okay.
all melting,
So,
it will happen.
nope. Depends on the temperature. Ammonia, the last part of this thing says that ammonia melts at -77. If I get colder than -77, is it going to melt?
No.
Nope, and that's what's happening in C. C is even colder. That's not gonna happen. The delta G in C then would be positive, because it ain't gonna happen. Okay? So, what if it was at negative 77.7? What's the delta G gonna do there?
It's gonna be negative or zero.
It's gonna be zero. It's at equilibrium. That's what it is, right? At the melting point, it's at equilibrium. It's going back and forth. So at B, it's zero. The sign's not positive or negative. It's right there in the middle. Okay?
And that one would be negative.
For A, will it melt at negative 60? Well, yeah, y'all, if it'll melt at negative 77, negative 60 is hotter. It's definitely gonna melt there. Right? So what's the sign of delta G for A? Negative. Mhm.
This has nothing to do with that, I just kind of thought of it. So, okay, so for conversion to Celsius to Kelvin, is like you add, subtract 270.
Celsius to Kelvin is add 273.
Yeah, so is there no such thing as like colder than 273 Celsius?
There's no such thing as colder than negative 273.15 Celsius. Because that is 0 Kelvin, because that is absolute zero.
Yeah.
So, zero.
That makes much more sense.
Okay,
I think I was looking for math and did not know where to go from
Right.
there.
right. And you could math that by looking up a ton of delta G's,
Yeah.
but that's way more work than we need to do. We can reason that out.
Okay. And then on the last one, I just didn't know what U was, like what it stood for, number 57.
Oh, number 57, which following, sorry, I'm reading it and y'all aren't, so let me read it to you. Which of the following thermodynamic functions are associated with the first law of thermodynamics? What does the first law of thermodynamics say?
Energy is not created nor destroyed, only transferred.
First law of thermodynamics.
More.
Energy
Yeah.
Can that be created in order?
is neither created, here I go, nor destroyed, but is transferred from one form to another. Mhm. Michael, does that looks like Michael's writing, right? I give. I've been giving Michael a hard time since January over penmanship. So don't write it like that. That's what first law says. And then it says, his is not that bad, I'm just teasing. Does it apply to entropy? S. First law applies to heat and internal energy. That's me
That's
answering your
U?
question. U is internal energy.
I remember that.
Uh-huh,
but
that's
I
Chem
was
1.
like, I didn't know if that was. I knew it was a sign for some kind of energy, but I didn't
Yes.
remember it from this chapter.
Yes. So the answer to that, yeah, is U and H.
Okay.
In Chem 1, y'all go, when I write this, I'm hoping y'all are going to go, oh yeah. That's okay if you don't. But do y'all remember delta U is equal to Q plus W? Okay, I'll take a kinda. That'll make me happy. Okay, and just this chapter, the delta H of the universe is equal to the delta H of the system plus the delta H of the surroundings, yeah? But isn't the delta H of the universe 0? Yeah, that's all that's first law. So.
Is that going to be on the board? Delta H?
Of the universe?
Yeah.
No, because the universe is always a system in the surroundings.
Okay.
That might be useful to remember, though.
Okay.
Was that the last one? It's a pretty handy little review.
Where did we grab?
Hang on, I'll jump back a slide for you.
Okay, it's. Yeah, okay. How did we grab the 0.27, 0.4?
Oh, those were in the problem. The
In the-
book
Oh,
told us those.
okay. So
Yes.
the book told us those?
Yes.
Okay.
It gave you, it says the partial pressure of PCl5 is
Oh, okay. Okay, gotcha.
.0029 and PCl3 is,
Okay.
yes.
That's the only part I was.
Okay.
If you can answer this, will that be something we need to concern ourselves with?
Like using that formula?
Like the partial pressure thing?
Okay, possibly.
I already said
My
that.
answer is I don't know.
Okay.
I don't know what's on there. Can't remember.
Okay.
So, if it doesn't, like in this one, it gave you these as partial pressures, because that's how you report the concentration when it's gaseous. Let's say this had said PCl5 aqueous in equilibrium with PCl3 aqueous and chlorine gas aqueous. Then it would have said the concentration of PCl5 is 0.0029 molar.
And we would need to find Q with those
And
concentrations.
it's the same thing.
Okay.
It's the same thing.
Okay.
Yes,
So
It's-
definitely know how to do that formula.
Right.
And where to plug it. Okay.
right. But don't let it throw you if it says partial pressures versus molarity.
Yeah.
A lot of the equilibrium stuff we did was molarity,
Okay.
but pressures is nothing. It's just numbers with different units.
Okay.
But I don't work it any differently.